Next unit is hydrocarbons. What are hydrocarbons? Hydrocarbons are the compounds which are made up of carbon and hydrogen. The compounds which are made up of carbon and hydrogen, these compounds are called hydrocarbons. Hydrocarbon is an organic compound. Yim organic compound banemi carbon and hydrogen. These hydrocarbons are divided into three different types. Hydrocarbons are divided into three different types. Number first is saturated hydrocarbons. Number second is unsaturated hydrocarbon. And number third is aromatic hydrocarbon. Hydrocarbons are of three different types. Number first is saturated hydrocarbon. Number second is unsaturated hydrocarbon. And number third is aromatic hydrocarbon. Agar saturated hydrocarbons, saturated hydrocarbons are those hydrocarbons which contain single bonds. Human hydrocarbon means single bond as in present. Those hydrocarbons which contain single bonds, that hydrocarbons are also called as, these are called as saturated hydrocarbon. The team compound is human compound means single bonds as in present. These compounds are called saturated hydrocarbons. And these saturated hydrocarbons are also called alkene. Saturated hydrocarbons are also called alkene. Whereas unsaturated hydrocarbons are those hydrocarbons which contain double bond or triple bond. If hydrocarbon contain double bond, then these hydrocarbons are called alkenes. And if they contain triple bond, then these are called as alkynes. Unsaturated hydrocarbons are of two different types. Number first is alkene and number second is alkyne. Now in case of saturated hydrocarbon, the general formula of saturated hydrocarbon is CnH2n plus 2. Agar general formula which is alkene general formula is CnH2n plus 2. And CnH2n plus 2, whereas N indicates here number of carbon atoms. N is number of carbon atoms. Agar general formula which was hydrocarbon alkene, that formula is CnH2n plus 2, whereas N is the number of carbon atoms. And the value of N starts from 1, 2, 3, etc. Now, if the value of N is 1, agar by N is the value is 1, formula ban mein C1H2 into 1 plus 2. Will you kaatne barabar CH4. This CH4 is simply called methane. If agar by N is the value 2, formula ban mein C2 2 into 2 plus 2, that is C2H6. C2H6 is ethane. So these are simple classification of hydrocarbon, saturated hydrocarbon and unsaturated hydrocarbon. But the new term is aromatic hydrocarbon. Dekho, these are those hydrocarbon, aromatic hydrocarbon. These are those hydrocarbons which contain at least one benzene ring. The hydrocarbons which contain at least one benzene ring, these compounds are called aromatic compounds. Aromatic hydrocarbons are tiem compounds. Human compound means benzene ring present. Benzene ring is cyclohexene लगभग 100 में चलो बुट्टा खेल दिए aromatic compounds for example benzene agar benzene which ho benzene is cyclohexene which contain three alternate double bonds. The hydrocarbons which contain three alternate double bonds, this hydrocarbon is called aromatic compounds or aromatic hydrocarbon. For example benzene, agar a simple benzene, this benzene is aromatic compound and this benzene is also hydrocarbon. Now you write down the heading. What are alkenes? What was alkenes? Then we start alkenes. So what is alkene? These are the hydrocarbons, alkenes. These are the hydrocarbons which contain double bonds between the carbon atoms. First heading is alkene. Alkenes are the hydrocarbon which contain double bonds between the carbon atoms. Those hydrocarbon which contain double bond between the carbon atoms, these are called as alkenes. These alkenes are also called, the double bond is also called olefinic bond, OLEFENIC. The compounds which contain double bond, this double bond is also called olefinic bond. Olefinic bond means which form the product which are oily in nature. Product oils, most of the oils, these contain olefinic bonds or these contain alkenes. That is why the double bond is also called olefinic bond. Agar alkenes which hydrocarbon double bonds present. And you see double bond yaad rakhna alkene and alkene mas agar reactivity hunis compare karo, alkenes are more reactive as compared to alkene which contains single bonds. And a human compound mas double bond human compound mas triple bond these are more reactive. Alkenes are more reactive as compared to alkene. For example, CH4 and CH2 double bond CH2. Now the question is, out of this and this, out of ethane and out of methane, which is more reactive? Reactivity depends upon the double bond. As the number of double bonds increase, reactivity of compound increase. So reactivity should directly depend on. Reactivity is directly proportional to number of pi bonds. As the number of pi bonds increase, reactivity increase. And you know there are two types of bonds. One bond is sigma bond and number second is pi bond. Sigma bond is formed due to the overlapping of orbitals along the axes, whereas pi bonds are formed due to the sidewise overlapping of orbitals. Since we know out of CH4 and C2H2, CH4 does not contain any pi bond. That is why it is less reactive. Whereas CH2 double bond CH2 contain one pi bond. Due to the presence of this pi bond, these alkenes are more reactive as compared to alkane. And this CH triple bond CH is more reactive as compared to alkene. So order of reactivity is alkyne are more reactive as compared to alkene. The reason is that in case of alkyne, there are two pi bonds. Agar alkyne mas visho, alkyne mas chasan two pi bonds and one sigma bond and two pi bonds. Yaad rakhna, pi bonds are weak bonds as compared to sigma bonds. तो अगर इस पाई बॉन्ड तो सिग्मा बॉन्ड दरमियान कंपेयर करो, पाई बॉन्ड वीक बॉन्ड एज कंपेयर टू सिग्मा बॉन्ड. अगर pi bond as breakdown curve. If we want to break this pi bond, then we need bond dissociation energy equal to 264 kilojoule per mole inverse. And pi bond breakdown करने खातिर ऐसे energy शलागन बका. That is equal to 264 kilojoule per mole. But in spite of sigma bond, अगर sigma bond breakdown as करूं, it needs 398 kilojoule per mole. So from this data, it is clear that the sigma bonds are strong bonds, whereas pi bonds are weak bonds. इधर जो था उन याद अगर इस अल्कीन तो अल्काइन दरमियान रिएक्टिविटी हुनार बुझो अल्काइन चाहसन ज्यादा रिएक्टिव क्या जी क्योंकि उमन मंशन नंबर ऑफ डबल बॉन्ड्स ज्यादा as the number of double bonds increase the reactivity is increased. The main reason is the pi bond is weak bond and as a result it will easily break as compared to sigma bond which is strong bond. Thus the order is alkyne are more reactive as compared to alkene and as compared to alkane. So this is all known as what is alkenes. Alkenes are the hydrocarbons which contain double bond between the carbon atoms. These are those compounds which are more reactive as compared to alkene. The reason is that alkene contain pi bonds and as the number of pi bonds increase, reactivity increase. This is because reactivity depends upon number of pi bonds and pi bonds are weak bonds as compared to sigma bonds. Now you write down next heading, structure of alkenes. Structure of alkenes. First point you write, the hybridization of alkene is sp2. Hybridization of alkenes is sp2, whereas hybridization of alkene is sp3. Alkene sp2 and whereas in alkenes hybridization is sp3 and in alkyne it is sp. First important point is alkenes, structure of alkene. The structure of alkene depends upon hybridization. We know alkenes have hybridization sp2. Alkene में हासन sp3 और alkyne में hybridization हासन sp. Now when at the organic compounds में hybridization as find out कर, we have to calculate only number of sigma bonds. In case of alkene, for example CH and H, there are 4 bonds between the carbon and hydrogen. Since all the bonds are sigma, that is why hybridization should be sp3. Number of orbital is here 1, 2, 3 and 4. Once we have 4 bonds, that means we have to add up the 4 orbitals sp3. But in case of alkene, the hybridization is sp2. Why it is sp2? Because there is only 3 sigma bonds. 1, 2, 3. 1, 2, 3. As a result, here is hybridization is sp2 and in this case hybridization is also sp2. But in case of alkyne, since in case of alkyne there is only 1 sigma bond, there is only 2 sigma bond. Between the 2 carbon atom there is 1 sigma bond and between the carbon and hydrogen atom there is 1 sigma bond. As a result, hybridization should be sp and in this carbon hybridization is also sp. Now it is clear. In case of alkene, hybridization is sp3, sp2 and sp. Always remember, as the character of S increase, as the value of S increase, the acidity is also increase. Acidity depends upon the percentage of S character. In case of alkynes, the percentage of S character is here 50%. 50% S and 50% P. In this case, percentage of S is 25% and in this case, percentage is 35%. Now, as the percentage of S character increase, electronegativity is also increase. याद रखना ये साथ S percentage increase गसन electronegativity च तीचा increase गसन और ये electronegativity increase गसन acidity is also increase. Now, out of alkene and alkyne, the alkynes are most acidic as compared to alkene and as compared to alkyne. This acidic order, acidic nature depends upon S character. The acidic nature depends upon S character. As the S character increase, the acidic nature is also increased. This is because as S character increase, the electronegativity is also increased. So electronegativity should depend on S aspect. If the S character increase gasan, tuta should carbon and hydrogen is electron between carbon and hydrogen. Carbon will attract this electron more towards itself. As a result, H positive will release easily here, as compared to alkene and as compared to alkyne, and as a result acidic character will follow. Acidic character is alkyne are more as compared to alkene and as compared to alkyne. The first important point is in case of alkene the hybridization is sp2. Now write down second point. In case of alkene, the carbon hydrogen, in case of alkene, the carbon hydrogen bond, in case of alkene, the carbon hydrogen bond is formed due to the overlapping of S and sp2 orbitals. Suppose this is the case of alkene. In this case, you know, suppose it is double bond. Hybridization will be sp2 and hybridization will be here sp2. Yet carbon sp2 sp2 hybridization, yet carbon sp2 sp2. इसका मतलब ये हुआ this carbon possesses 3 orbitals and this carbon also possesses 3 orbitals. Yet carbon sp2 3 orbital, this carbon sp2 3 orbital. When you start this bonding bond, we show carbon. Now carbon contain 3 orbital 1, 2 and 3, and next carbon. Now in this case this carbon possesses 3 orbital sp2 and sp2 मतलब 3 orbital change was 1, 2 and 3 और ये इस carbon स्पेसिस 3 orbital 1, 2 and 3. Now sp3 मतलब वो 8 orbital जो carbon में so यिम hybridization में part new came and these orbitals are called unhybridized orbitals. You know this thing, unhybridized orbitals. Unhybridized orbitals are those orbitals which does not take part in hybridization. Now from this structure it is clear. Carbon has sp2 1, 2 and 3 orbital. 1, 2 and 3. This is unhybridized. When you are hydrogen, hydrogen is here 1s and hydrogen is here 1s orbital and 1s. You know, in case of carbon, the electronic configuration of carbon is 2 and 4. Last shall contain 4 electrons. 1 electron is present here. 8 electrons here the orbitals is present. 8 hydrogen is 8 electron. 8 bond bane m side. M side bane 8 bond. इधर कौन से hydrogen is 8 electron, carbon 8 electron and hydrogen and carbon. In this case the structure is formed. And this type of structure, try to understand here. Carbon is 3 orbital, sp3. 8 sp2 orbital go overlap s. So in this case I can write here s and sp2 bond. S and sp2 किसका बनो? sp2 8 orbital go overlap with s. इधर कौन सी है? sp2 and s orbital. And same is the case here. And next orbital is formed between the overlapping of carbon. You write down next point. The unhybridized orbitals. The unhybridized orbitals which are present. The unhybridized orbitals which are present in carbon atoms. In carbon atoms possess one electron. As a result, they will overlap sidewise. As a result, they will overlap sidewise and form pi bonds. Now see, this is carbon, single bond carbon, single bond hydrogen, hydrogen and hydrogen. Yaw this samajh dikkat kya bana ye molecule. Carbonus mazas sp2. sp2 matlab go sar में 3 orbital, 1, 2 and 3 orbital. Arc orbital को use overlap with 1s acid, that is hydrogen acid बनियो arc bond. और ब्याक sp2 orbital को use with another hydrogen बने is bond. और ब्याक sp orbital को use with carbon बने bond. And in this case, one orbital is unhybridized, and this orbital contain one electron, and this orbital contain also one electron. Now this is carbon, for example. This orbital is unhybridized orbital, and unhybridized orbitalus manchi yet mas the electron, or yet orbitalus manchi electron. Now what will happen? This orbital and this orbital will overlap sidewise. When they overlap sidewise, sidewise overlap and they result in the formation of bond, and that bond is pi bond. Alkenes में जो pi bonds बना, it is because of the sidewise overlapping of two orbitals. Next important point is, अगर मैं alkene में, this alkene is flat molecule, and this unhybridized orbital is present above and below the plane. मैं समझाता है सामने वने कि alkene का अगर स्ट्रक्चर वुचो, suppose alkenes मंच वंकन कस bond attached, carbon carbon, this is one bond and this is another bond, this is carbon, येतन छ आख हाइड्रोजन, येतन छ आख हाइड्रोजन, येतन छ carbon, इथे कौन has back carbon, येतन तेमिस आज यम side the hydrogen, yam side the hydrogen, and these are present in single plane. If I pass the plane here, and these two hydrogen and carbon will cut, इस वन आख